artists and designers working with technology collaborate with living organisms in a way that is meaningful and mutually beneficial? And can this collaboration act as an essential demonstration of how our electronic-dependent society can change the way we consume and use personal electronics like phones and computers? We formed the artist collective SlimeVolt to determine exactly that. SlimeVolt is an artist-led collaborative that aims to disrupt the modern technology paradigm by incorporating biological components within existing electronic systems, not simply as a means to replace computer parts, but rather to foster a new kind of caring relationship with our electronics. The current culture around our consumption of electronics is entirely unsustainable. The almost immediate obsolescence of personal devices has led to an annual accumulation of 50 million tons of e-waste alone. Rather than simply providing new biological materials to replace electronic components that in turn would become a new kind of e-waste, our collaborative decided to address the cultural problems around overconsumption itself. As a group, we created an instrument that can act as a model for creating new kinds of symbiotic relationships with our personal electronics. We chose to collaborate with the organism Physarum polycephalum, a user-friendly protoplasmic slime mold used commonly in laboratory settings. Physarum polycephalum is a dynamic and fascinating organism whose unique abilities and physical intelligence has continued to resist classification and challenge the greater scientific community's understanding of intelligence. Physarum polycephalum has the ability to solve basic mazes and has impressive pathfinding capabilities. It also is able to respond and to thrive in states where it's exposed to electrical stimuli, making it a perfect fit for our foray into biocomputing.
Originally, we were introduced into biocomputing with the work of Eduardo Miranda, the Director for Computer Music Research at the University of Plymouth, as well as the work of Andrew Adamaski, who runs the Unconventional Computing Lab at the University of West England in Bristol. Adamaski, in particular, has been researching slime mold for over 10 years, and in his text, Physarum Machines, provides us with an experiment that allows us to measure slime mold's electrical potential. In this setup, we would place conductive tape on two ends of a petri dish filled with agar. By attaching slime mold's favorite food on either end, which are rolled oats, slime mold would grow in between the two parts and create an electrical bridge. We would then measure this connection as a resistance value. We found through this experiment that as slime mold grew, its resistance would increase proportional to its growth. We then took our setup into what's known as an oscillator circuit, which takes an electrical current and turns it into a square wave. So this is plugged in. That's so cool. This is our slime sound. This design is at the core of so many early electronic synthesizers and costs only a few dollars to create. In our circuit, we were using a 3-volt battery, which is the size commonly seen in hearing aids, and outputs a safe voltage that should have no effect on our cultures. As a group, we were able to create over 50 plates and found no harm in the organism in any of our experiments. We were then able to create personalized setups to play with and perform with each other.
Oh, wow.
Turning slime mold cultures into an 8-step sequencer, or plugging it into an old toy and hacking how it used to sound. We then shared our progress in class critiques and got feedback from students and faculty, as well as artists and musicians around Chicago giving us some of their best advice. Through this experimentation, we became fascinated by the care relationship that began to develop between ourselves and the organism. This began to fuel our philosophy on collaborating with living components in electronics. To begin to put these ideas to test, we narrowed our scope towards DIY electronics communities, making our practice accessible to them by designing with readily available devices and sharing our entire protocol on existing platforms, as well as on our website with instructional videos on how to get started. In our latest model, we designed a terrarium for our slime molds to live in. We've attached our analog circuit that we mentioned previously alongside with the new integration of a Raspberry Pi. This has allowed us to add in a functionality for time-lapse recording and measure in data such as temperature and other parameters to further push our care element, with an overall goal in providing an open source and customizable setup to care for and record information from SlimeVolt. As a collective, we believe that by introducing individuals on how to care for living organisms within existing machines, that we can foster a new kind of relationship with our electronic devices that encourages collaborations with the living world.